Hello students, welcome to video lecture on C programming. In this lecture, I am going to discuss formatted input and output. In earlier lectures, we have seen scanf function, printf function, getS, putS, getChar, putChar functions for input and outputs. Now here we will see formatted output as well as formatted input. Now this is window, programming window. In this programming window, we write a program. So I have taken simple example here, and we are printing here. We have used printf function. So printf in bracket in double quote output of the program \n. \n it is used to go for new line. And then printf in bracket double quote j is equal to %d, y is equal to %f, double quote is completed, comma j, comma x bracket is completed. So here y is floating point number and j is integer number. If we run this program, we will get output. So this is output of the program. We got j equal to 13, y equal to 2.3400000. Now here this is output screen. Output screen in text mode. Text mode. So if we see here from this corner to this corner and from this corner to this corner. So this is first line and this is first character, second character, third character and so on. So on the first line 80 characters can be printed. And if we take the here second line, third line, fourth line, so on, there are in all 40 lines on output screen that we can see, means that are visible to you. So it is 80 by 40 screen. So 80 characters on one line and there are 40 lines. So each character will require a space. So if we take output, output will require 6 places and that is called width. So here we can format output using this space or width. So let us go to formatted output first. So formatted output and it is for integers. The general format for printf statement is printf in bracket in double quote we have control string and then argument 1, argument 2, argument up to argument n separated by comma. Bracket is completed. And in control string we may have format specifications. For example, %d for integer data type, %f for float or double, %e for float in or real number in exponent form. Then you can have qualifiers for this also. Long unsigned int, unsigned int and so on. So suppose we take integers. So %d it is used. And you can use %wd also, where w is called width, specified width for specification. If we see simple example, suppose we have int I is equal to 2368. So there are 4 digits here. So 4 places required to print these 4 digits on the output screen. Suppose we take printf function like this, printf in double quote percent d comma I. So what happens? First four places are taken by the number and remaining places are vacant. Remaining places are vacant. But if we take here printf in double quote percent 6d comma I. So here 6, that is W width. What is meaning of this? So specified width is 6. So 6 places are reserved to print the number I. But I has only 4 digits, so 4 spaces are required. So what happens here? These 6 places are reserved, out of which 4 places are used, and it is right justified. So these first two places remain vacant. Remain vacant. Now if we take printf in double quote percent minus 6d, minus, this is called flag. So again here W is 6, so 6 places are reserved, but number is printed like this. So what happens? Last two places remain vacant. You can print another number here, but these places will remain vacant. Now if we take here next one, printf in bracket in double quote percent 0d comma I. Now again here width is 6. Width is 6. And here we have flag 0. So what happens? 6 places are reserved. Number is printed like this because we have 4-digit number, and initial places that are 2 now here, they are filled with zeros. They are filled with zeros. If we take here next one, printf in bracket in double quote percent 3d comma I. Now what happens? Width is 3 here. Minimum width required to print this number is 4. So specified width in the format specification is 3, required width is 4. So what happens here? Simply this is ignored. Ignored. And it is printed, number is printed as it is like this first one. So no specification is taken, width is taken. So in this way you can format output for integers. Similarly, you can format output for floating point numbers also, or for real numbers also. We know F type conversion and E type conversion are both used to output floating point values. The format specification for printing the real number is percent %w dot pf or percent %w dot pe. What is W? W is the minimum number of positions that are to be used for the display, and P is the number of digits to be displayed after decimal point. So that is also called precision. If we take example here, float x is equal to 23.4567, and if we use here printf statement, printf in bracket in double quote percent %f comma x. So what happens here? 1, 2, 3, 4, 5, 6, 7. There are 7 digits with one decimal point. So 7 places or positions are required. But by default, it will take 6 decimal places. So additional 2 decimal places are taken. So in all, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 positions are used by default. But if we take here printf in bracket in double quote percent at f x. Now what happens here? How many positions are required? 9 positions or places are required. But here width is only 8. So simply it is ignored, and it is printed like this. But if we take this like this, printf in double quote percent 8.3 f comma x. So precision is 3, p is 3. So only 3 decimal places are taken. So 3 decimal places, decimal point, and 23. So in all, 6 positions are required. So what happens here? There are 8 positions reserved. Out of that, 6 are used. So it is printed like this. So these 6 positions are reserved. But since P is 3, it will take 3 decimal places only. So it is rounded up. Number is rounded up. And 6 places are used, and initial 2 will remain vacant. Initial 2 will remain vacant. If we take like this, printf in bracket in double quote percent 8.2 f x. So precision is now 2. So only 2 decimal places are printed. So if we take here, number is rounded 23.46. So 5 positions are required. Width is 8. So 5 positions are used, and it is right justified, and initial 3 remain vacant. Initial 3 remain vacant. Now if we take this one, here flag we have used minus. So what happens? It is printed with 8 reserved positions. Only 5 positions or places are used, but it is left justified. So what happens? Last 3 places remain vacant. You can print another number here, but these 3 places will remain vacant. Now if we take next one, so printf in double quote percent ex. So it is e type conversion in exponent form. So the number is printed like this: 2.34567. So 6 decimal places are taken. Then we have e plus 0, 1, 10 raised to 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 positions are taken. 12 positions are taken. But if we take here printf percent d 10.2e. So width is 10, precision is 2. So what happens here? This number will take only 2 decimal places. So 2.35 into e raised to 1, 10 raised to 1. So 2.35 e plus 0, 1. So 1, 2, 3, 4, 5, 6, 7, 8 places are used, and first 2 places remain vacant or positions remain vacant because here width is 10 and only 8 is required. 8 is required. So in this way you can format output for real numbers also. Now formatted integer input. So we know for input we use scanf function, and then in general percent %d, suppose I, like this. So percent is conversion specification for integers, and W, it is the maximum width of the input data. If the length of the input is more than the width, then values are not stored correctly. Means suppose here we have percent %3d, and suppose I is 2348, but width is 3 and number has requires 4 positions. Then this number, it is not properly stored in the memory location. For example, if we take here, I have two arguments, I and j, then percent %2d, percent %3d. So for I, width is 2, for j, width is 3. Suppose values entered are like this, 5 and 34. So what happens here, since this is 5, so only one position is required. This is 34, two positions are required. Here for I, width is 2, and for j, width is 3, so width is more. Width is more. So these numbers are taken properly. If we take this one, now for I, width is 2, number is 15, two positions are required, so no problem there. For j, width is 3, number is 341, so it is taken properly. So first one is properly taken, second one is properly taken or stored properly. But if we take this one, 158 and 341. Now here width is 2, here width is 3. For I, width is 2, for j, width is 3. But given number I is 158, that is 3-digit number, j is 3-digit number. What happens in this case? 15 will be stored at the memory location of I, and 8 is stored at the memory location of j, and remaining is ignored. Means what happens here? In the last case, since I has width of 2, only 15 is stored, and in I, stored in I, and 8 is stored in j, while the rest of the input is ignored. Rest of the input is ignored. So while specifying width for inputs, you have to take this care. You have to take this care. Now suppression character. What is meaning of suppression character? If we want to skip any input field, then we specify star between the percent sign and the conversion specification. Means you can specify like this, percent $d or percent $c, like this. Then that one is skipped. For example, if we take here simple program, suppose we have here hash include stdio.h, hash include conio.h, then we will take here main, then I will take here int, suppose dd, and y. These are three integers I have taken. Then I will take here clr scr, and here printf enter the date. So this enter the date is printed as it is on the output. Then we will take here scan f. Now I will take percent %d percent %c percent %d percent %c sorry here, and then percent %d. So percent %d percent %c percent %d percent %c percent %d. So I have taken in all 5 conversion specifications. Now percent %c means whatever character, that one is ignored. And I will write here and I and j and sorry and we have taken here and dd and dd comma and mm comma and yy, and now we will print this printf dd is equal to percent %d mm is equal to percent %d and yy is equal to percent %d dd comma mm comma yy and get ch like this. So I have used here percent %c and percent %c for suppression. Now if we run this program, you will get output screen, and on output screen you will get first enter the date as it is. And if we enter date like this 23/05/2020 like this, and if we see output, on the output you will get dd is equal to 23, mm is equal to 05, and yy is equal to 2020. Means this character, it is suppressed. It is suppressed. So 23, it is used for this first %d, for first %d. Now for this character percent %c, so it is suppressed. Then 05 here, this %d, then this character that is suppressed due to this %c, and this %d, it is for this. Now you can enter like this also. You will get the same output because these characters are suppressed. In this way, we can suppress characters, you can suppress integers also using this format, either %d or %c in this scanf function. So now we will see programs for this. So let us go to programs. Now we'll see simple program for formatted output of integers. So let us take program. So here hash include stdio.h. These are preprocessors. Hash include conio.h. Then main function, and here I will take variable that is integer variable. So declared as int I semicolon, then clr. This function is used to clear the output screen before printing the output of this program. Now here let us take I is equal to 2348 and now print this. Printf %d conversion specification and I. So printf in bracket in double quote %d comma I semicolon, and then I will take get ch function to get output on the screen. And if we run this program, so see here we got output 2348. Now number is 4 digits, so 4 positions are required. So it will take first 4 positions and cursor is blinking on 5th position. So you can use 5th position or 5th position and remaining positions to print other number. Now if we take here another printf function, so I will take here \n. So cursor will go to new line on the output screen. So printf, now in double quote percent I will give width 8d, double quote is completed I. Now number is 4 digit, width is 8. So 4 positions are required for number, but 8 positions are reserved. So if we compare first line with second line, you will observe that 8 positions are used for second function, second printf function, but first 4 positions are now vacant and cursor is blinking on 9th position. Now if we take here \n now, and I will print that here printf. Now percent minus 8d. I. And if we run this program, see what happens. Now see first line, no width is used. So by default it takes 4 positions. In second one field width is 8. So percent 8d. So 8 positions are reserved, out of which last 4 are used. So it is right justified. But if we see third one, we have used flag minus sign. So percent minus 8d. So 8 is field width. 4 positions are used for number, but it is left justified. And remaining 4 positions remain vacant and cursor is blinking on 9th place. Now we will take next one. Printf percent 08d comma I. Now here I will use \n. Now see here again field width is 8. So what happens here? number is printed with preceding zeros. Four places. Initial four places are filled with zero here because we have used flag 0 %08t. Suppose we take here \n and here printf double quote percent plus 8d. So this flag plus is used for sign to print the sign. If number is negative, it will take negative sign. But if number is positive, it will not take any sign. But what happens here? If we use flag, number is printed with positive sign here. Now next one. Here I will take \n again. And then printf %3d in double quote I, and now print here. Now here field width given it is 3. Positions required for the number are 4. So what happens in this case? If you see cursor is blinking on 5th position. So what happens? Given field width, if it is less than the number of positions required for the number, simply it is ignored. So in this way, you can format output for integers. Similarly, you can format output for real numbers also. So here we will change this program. So suppose we take here float x, then CLR SCR, then here x is equal to 23.4568. So given number is 23.4568, means 4 decimal places are given. Now we will print this number. Printf %f comma x. Printf in double quote %f comma x. Now if we run this program, now if we see from first position number is printed, and how many positions are taken? 23.456800, means by default it takes 6 decimal places. Our decimal places given to number are 4, 5, 6, 8. So remaining are taken as 0, 0. And width of this number. So number of positions required here are 9. So if we take here another printf function, so for that purpose I will give here \n, and here printf %8f in double quote comma x. Now what happens here? We have already seen 9 positions are required, but given field width is 8. So what happens? If we see first and second output, they are similar one. Cursor is blinking on 10th position. So given field width, it is less than the required width. So it is simply ignored. But if we take here, so I will take \n here, and again printf function, printf in bracket in double quote %8.3 f x. Now here precision is 3, means 3 decimal places will be used or printed. So here what happens? The decimal places are rounded up. Now if we take here, so here, since there are only 3 decimal places printed, required width is 6. So 1 is used for 2, second is used for 3, third is used for point, decimal point, fourth is used for 4, fifth is used for 5, and sixth is used for 7. But given field width is 8. So if we compare second and third output, first two places are vacant, or first two positions are vacant here. Now if we take here printf percent, printf in bracket in double quote percent 8.2 f double quote is completed comma x, and here I will give backslash n. So control F9. Now see here, 2 decimal places are taken. So number requires 5 positions. So first 3 positions remain vacant here. If we take same one here, but with flag, printf in bracket in double quote percent minus 8.2 f double quote is completed comma x, and if we run this, so there is one error. So what is that error? Printf. So control F9. I have to give backslash n here. Backslash n. So control F9. Now see here, 5 places are used, 3 are vacant, but number is left justified, and cursor is blinking on 9th place. Now I can print this floating point number in exponent form also. So I can write here print f percent e in double quote is completed comma x, and here I will give backslash n, and if we print, so if you see that last output, last line, that is number printed in exponent form, number printed in exponent form. Now see 2.34560, so 6 decimal places, then exponent e plus 0 1, power is 1, that is 10 raised to 1. So how many places are required? 1 2 3 4, then 6 decimal places, so 10 12 places are required, or 12 positions are required. So if I give here printf percent 8 e in double quote comma x, and here I will give backslash n. Now if we run here, so see here, last two outputs are same, because required width is 12, given is 8, so simply it is ignored. But if I take here 8.2, then what happens? Now see here 8.2, 2.35 e plus 0 1. So here 2 decimal places, they are taken, 1 2 3 4 5 6 7 8, 8 places are taken. So if we give here suppose 10.2, then if we observe, first 2 places are vacant, because 8 positions are required, or 8 places are required. Suppose we take number like this, printf in double quote percent 0.2 f comma double quote is completed comma x. So given width is 0 but precision is 2. Precision is 2. So what happens here? So width is ignored, only precision is taken. So here 23.46. You can take precision here 1 also. So 23.5. So it is rounded up. So in this way you can format your real number output also. Now we'll go to formatted input. Now if we see here, suppose we take here int I comma j, then I will remove this printf per se printf enter I and j. Now this string is printed as it is on the screen, and then I will take scanf function. Scanf. Now here percent d in double quote, then comma, then and I comma and j. So we are taking two variables, two inputs using scanf function, and we will print that I and f again. So printf in double quote I is equal to percent d space j is equal to percent d, double quote is completed comma I comma j, bracket is completed, semicolon. Now see here control F9. So enter I and j colon, that is printed as it is, and suppose we take 12 and 2 3 4 5. So here there is something error. So percent d, sorry, here percent d. Now control F9. Suppose 12 and 4 5 6 7. So I is 12, j is 4 5 6 7. So 12 is stored at the memory location of I, and 4 5 6 7 it is stored at the memory location of j. Now suppose we give here field width. So in scanf function, in control string I will take percent 2d, that is for I, and percent 3d, that is for j. So width given for I is 2 and for j is 3. So if we take 2 space 34, first will go for I, second will go for j, and they are stored at the memory location. So what happens, since given value of I is 2, that is only one position is required, but specified width is 2, so it will take, no problem. Similarly for j, specified width is 3, required width is 2 here, so it will take. Now if we run again, and if we take 23 4 5 6, again it will take, because specified width for I is 2 and given number is has two positions or two digits. Similarly, specified width for j is 3 and given number has 3 digits. So it will take, no problem. So properly stored at the memory location of I and j. But if we take input like this, suppose 2 3 4 space 7 8 9, then what happens here? So see here, out of 2 3 4, 2 3 will go for I and 4 will go for j, and remaining is ignored. So here input will not be stored properly at the memory locations. So before specifying field widths to the input, conversion specifications, you have to take care. Means how much you are going to take, means what will be the maximum value or maximum number of digits in that number, you have to consider that. So this is about formatted input and output. Now we'll go to separation characters. So I will change this program. Now suppose I take here int dd comma mm comma yy. dd for date, mm for month, and yy for year. Now in printf function, enter the date. So it is string, it is printed as it is. And now in scanf function, I will write %d, then %*c, then %d, then %*c, and then %d. So I have used %d, 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 then %*c, then %d, %*c, %d. So for separation of characters, I have used %c with star. And then I will write here and dd, comma, and mm, comma, and yy. And now we will print here. We will print dd is equal to %d, mm is equal to %d, and yy is equal to %d, and here dd, comma, mm, comma, yy. So these are variables. And if we run this, now here I have to give date. Now I can give date in any format. Suppose 23/02/2020. So see here, dd that is 23, mm that is 2, and yy that is 2020. So characters are suppressed here. Characters are suppressed here. Suppose we give here like this: 23 space 02 space 2020. So see here again it is taken 23 to 2020, means blank spaces are considered as character and that are suppressed. You can give any character here. Suppose we write here 23 question mark 15 question mark 2020. So that question mark is suppressed. So characters are suppressed. You can give like this also. Control F9 23-12-2020. So dash is suppressed. Dash is suppressed. So in this way you can format input and output. So we have seen these programs. So this is about formatted and input and outputs. If you like my video, I request you to subscribe the channel PST Edumedia if you have not subscribed. If you have subscribed already, then I really thank you, and also press like button. So thanks very much. In next lecture, I will discuss algorithm and flowcharts. So understanding of algorithms and flowcharts is necessary for effective programming. So thanks very much.